right? So now we're going to put the concept of slope and the definition of y-intercept together. So this equation, we call it slope-intercept form, all right? Y equals m times x plus b. M is your slope. And b is your y-intercept. All right, so now we're going to use that concept. Now notice the form before we jump into the problem. Y is on the side of the equation by itself. Okay, so that's the key. Now its coefficient, all right, is understood to be 1. So if you don't have something that looks exactly like this, y equals m times x, where m is some real number. It could be a fraction, it could be a decimal, all right? It could be a whole number. And b is your y-intercept. So you've got to have that form to be in slope-intercept form. So let's look at some examples. All right, so this first example says determine the slope and y-intercept. Now, the form you're looking for, right, is y equals m times x plus b. Now, remember, you have a understood 1 in front of that y. If that's not the case, you need to potentially divide everything by the coefficient of y. So, this first example, you've got y equals 7x minus 12. So let's put our 1. We have our form, so the slope and then we've got the y-intercept. So our slope in this case is 7. All right, our y-intercept is negative 12, but we're going to stick to our definitions and realize that this is a point. So it's 0, negative 12. Okay? Real simple. All right, so the first one is done. Second one, 2 times x minus 3y equals 12. Now, it doesn't have the form that we need, so we've got to manipulate the equation. So the first thing that we want this y by itself. All right, so the first thing that we're going to do is we're going to move this 2x to the right side of the equation via subtraction. So 2x minus 2x goes to 0. We're left with negative 3y equals negative 2x plus 12. So now we're closer to our form. All right, again, but our goal is we want y by itself. So that means we've got one more step. We need to get rid of this negative 3. In algebra, it's about balance. We're going to divide the left side by negative 3, and then we're going to divide every term on the right side of the equation by negative 3. The left sides, the negative 3's cancel, and we end up with y equals. All right, you've got negative 2 over negative 3, so just the negatives cancel, so that's 2/3 times x plus, well, actually we have 12 divided by negative 3, which is minus 4. So our slope in this case is 2/3. It's always the coefficient of x. Don't say x is your slope. All right, it's the coefficient of x. Our y-intercept is negative 4, but we're going to write it as a point as well, which is 0, negative 4. Now, to graph, I know that's not in here, but if we want to graph either one of these lines, we would plot our y-intercept, and then we will use the concept of slope to find our second point. And I guess I'll do it here. Let's use this example. See if I've got enough room. So let's erase this guy. And we want to plot this line for problem B. So you label your X and your Y axis. Again, those are just traditional variables. We can use A and B if we wanted to. So our y-intercept is -4. That's your starting point. All right. The slope is 2/3. So from this point, 0, -4, slope, again, one concept of slope is the rise over the run, which simply means we would go up 2 and right 3. So up 2, right 3. Draw your second point. Once you have your second point, you can draw your line through the points. So that's a concept. That's how you use the definition of rise over run to draw the equation of a line using slope and y-intercept.